Believe it or not, the same cables that hold the road deck could pose a mortal threat to the bridge. Not because of earthquakes, not even because of gale force winds. Just a gentle breeze can be lethal. Nearly 10,000 kilometers away in Baytown, Texas, the cables of the Fred Hartman Bridge began to look a lot less than solid. Spring 1997, 2 years after the bridge opened. In winds as low as 18 kilometers an hour, the cables bounced up and down ferociously. This happened time and time again. The structure suffered 100 separate stress failures, which could have been disastrous. Fortunately, the Texas Department of Transportation had been alerted and fixed it by tying all the cables together, holding each other down. The same conditions that threatened the Fred Hartman Bridge are a risk to any lightweight round metal structure, such as a cable, a tower, or a chimney. The Emily Moore TV mast in Yorkshire, England, was constructed in 1964, one of a new generation of lightweight structures built of metal rather than brick. In 1969, in light winds, the tower collapsed without warning. Ice buildup was blamed initially, but British aerodynamicist Kit Scruton knew it was due to a bizarre aerodynamic effect.
It's called vortex shedding, and it's nowhere near as difficult to understand as it sounds like it's going to be.
To demonstrate, I've got a fan and that metal pole over there.
So, let's make it a windy day.
That vibration is caused by swirls of air. This specially shot footage shows exactly what's happening. You can see the swirls moving from side to side. That's called vortex shedding. Any round structure creates these swirls of air, which can pull it one way and then the other.
You've got to remember, of course, that that's not the wind buffeting it. It's not gusting that's causing that shaking to happen. It's one vortex being shed after another that makes it vibrate like that. And a further problem there is if this goes on long enough, shaking and shaking and shaking, the metal itself will fatigue. It can be a catastrophic failure.
It moves towers from side to side, and it can move cables on bridges up and down, as the Fred Hartman Bridge in Texas can testify. Fortunately, British aerodynamicist Kit Scruton worked out how to overcome the lethal threat from vortex shedding. He invented the helical strake. A helical strake is a strip of metal that winds like a big coiled spring around the top of tall steel towers today. It keeps them safe from the powers of vortex shedding.
Yeah, now I know it looks like what I've done is tie blue string around another tower, but this is more than that. This is a helical strake. The theory runs, what this does is, as the wind arrives at the structure, instead of a vortex forming the length of it, rolling around and shedding, and then another one, which sets up that movement, it breaks those vortices up. And that simple act, breaking them up and changing the time at which they come around, evens the whole process out. No vibration, no failure of the structure. That's the theory. Now I'm going to make it a windy day and test it. So my blue string, helical strake, works.
And now you can see them everywhere. Just take a look next time you're out. And back on the Rion and Tyrian Bridge, every cable is fitted with one of Kit Scruton's helical strakes. They break up the wind hitting the cables to protect the bridge from vortex shedding. On top of everything else, To accommodate for the fact that Rion is moving away from Antirion, the bridge has the largest expansion joints in the world, allowing for the two coasts to drift 5 meters away from each other.